Review right there. That's a review. Oh, you know what, you guys? Forgive me. When I typed in the definitions, it screwed up the formatting and I didn't realize it. So this is supposed to be over here. I was going to make new copies this morning and I forgot. So what you're doing today is a radical function is a function that contains a radical with a variable in its radicand. Ooh, do you remember what those words are? Here's a function. It contains a radical. It contains a radical and what? And whatever's underneath it is called the radicand. So that's a radical, that's a radicand. So there's a radical function right there. Oh, there's lots of other ones too, but... All right, so parent functions. Let me just review. When you take the square root of x, you get a positive x and a negative x, correct? With an even root, right? Okay, I'm showing you this for a reason. Because the parent function is f of x for square root is just this. Did I put anything in front of here? Did I put a positive r and a negative? No. So the parent function is just positive. That's the only part you work with. Okay? So therefore, that makes the graph kind of funky. Make a table. Yes, you're going to have to do this today. You're going to have to get some points off the table on the calculator to sketch your graphs. Just kind of a good habit to get into. So if I were to plug 0 into this, what would my y be, my output? Is the square root of 0? 0. What's the square root of 1? 1. What's the square root of 4? 2. These are 3 points. When you have to sketch the parent function, they're real easy to sketch. So 0, 0, 1, 1, 4, 2. Boom. That's the parent function. This is what you're going to shift around today. Okay? Just that piece. And the reason it's only the half of the parabola is because we're only using the positive. Got it? Okay. The other parent function is cube root. All right, so let's just make a couple of points again that will fit into this. So what's the cube root of 0? What's the cube root of negative 1? Some of you know. Yeah, some of you, I want you to think about. Some of you, do you know what the cube root of negative 1 is? Negative 1. Negative 1 times negative 1 times negative 1, right? And the cube root of 1 is what? 1. So let's plot those 3 points. 0, 0, negative 1, and 1, 1. Now, if you were to go to the graphing calculator, I call it a snake. That's what sexy algebra teachers called it, so I've always called it that. That I had it. I told you guys that I had it. I had it, yeah. He was really cute. Wait, what? Got their attention, didn't I? When I first went back to school and decided I was going to be a math teacher, I had a really, really sexy algebra teacher. He was so much fun to watch. I was married, but, you know, whatever. Made it entertaining. So he called this a snake. I don't know what your other teacher, I always call it a snake. Okay? All right. So these are the parent functions you're going to be shifting around. Easy enough. What happens when we multiply the outside of the radical with a negative 2? What's going to happen to my function? Stretch by 2 and do what? And flip. So I do want you to just do a quick little sketch. Remember, it's 0, 0, 1, 1, 4, 2. And just kind of do a dash. That's your parent function. Yeah? How much has this gone up here? I'm just going to put a little 1. It's going up 1, isn't it? It's going up 2, isn't it? Here. If I'm going to multiply it by negative 2, my output is going to be doubled. So I'm still going to start at negative 2, but my output's going to be doubled. So that point's going to go down. Double and double. This is a graph of that, whatever you want to call it, translation, or I don't know what you want to call it. Now, if you're like, what, I can't do that, go to your calculator. Put this in and get a couple points, okay? But if you really think about it, all it's doing to your output is doubling it and making it negative. So your y values are changing by that. Does that make sense? This has gone now to 2. This has gone to 4. See, the y values have doubled. If that's too weird for you, just don't think too much about that. Go to your calculator and get some points. Okay? All right, let's do another one. This is a 3/2. Is that greater than 1? So what's it going to do to my snake? Stretch it. It's going to stretch it. So I want you to draw the parent function. Just kind of sketch that. It's something like that. That's the parent function. And then let's think about what's happening to the outputs. They're being multiplied by 1.5, right? Let's look at it that way. It's still 0 here because 0 times 1.5 is 0, yes? 1 times 1.5 is 1.5, correct? You with me? Yeah. Okay. Negative 1 times 1.5 is what? Negative 1.5. So 0, 0 stays the same. This one goes to 1.5. This goes to negative 1.5. And that's kind of what it would look like, sort of like that. Does it flip? No. Again, if you're baffled by what I did in my head here, just go to your calculator. I don't care. Get some points off of there and see what happens, okay? Flip it over. All right. Biologists have found that the shoulder height in centimeters of a male African elephant can be modeled by this function right here, where T is the elephant's age in years. Oh, I was going to shift all this, so I made notes to myself last night and I forgot. Oh, well, we just have to squeeze. We got to squeeze. T is the elephant's age in years. Can T be negative?
Oh.
Why can't T be negative?
You can't have negative.
Thank you. T can't be negative because age is positive. So that's going to kind of help me sketch it. I'm not going to have any negative x values. So I just want you to draw kind of a little like x and y axis here. X represents what? Age, which is actually represented as t here. This axis represents what? Height. Let's think about what we know from the equation. What's the starting height in this equation?
75.8.
Do you recognize that? All of you. Some of you do. Some of you may not. This number right here is the starting height. Just like in a linear equation, it's like the y-intercept. Right? So I'm going to just mark that somewhere here. I'm going to say, okay, this is 75.8. That's the starting height. That's where my little funky graph is going to start. So I want to, let's see, male can be modeled with T as the, I'm going to just go up by 1, 2, 3, 4, 5, 6, 7, 8. Let's just see how far we get with that. Now let's go to the calculator. And I do want you to throw that on your calculator, that function.
It looks ugly.
It does look ugly, but we'll work with it.
Yeah. It doesn't make sense.
So before you go anywhere, you know that you have to see how high on your y-axis, at least how high do you need to see on your y-axis? 75.8. So you got to change your y-max in your window. I'm going to take it up. What were they asking me? Wait. What did they ask? Look what they asked me here. Oh, look what they asked me in this part of the problem. Estimate the age of the elephant whose shoulder's height is 200 centimeters. This is the current shoulder height, so I should probably put my Y window all the way up to 220, 250 maybe? Okay, so let's go here. I don't need any X negatives, do I? I don't need negative H. I can keep this at 10, that's okay. I don't really need negative height, but I'll leave it at negative 10. Oh, look, this is from yesterday when I was doing this. Put the Y max at 250. Because they're asking me in the next part of the problem, what's the age at a height of 200? So I'm going to put 250, and I'm going to go up by 10s so it's not so squinched. Okay? And then graph it. Brian, did you do it? No, it's much prettier if you use these numbers. There it is. Look at that. Did I get that on the first try? No. I just kept adjusting it until I got a good picture. Okay? Now, what are they asking me here? So I'm going to sketch this. It's something like that. That's a sketch right there. Estimate the age of the elephant whose shoulder height is 200 centimeters. Well, what could I do? I could do a table. I could stick 200 in here and solve for t. That's a pain in the butt. Or I could do trace. Right? Trace on the graph. Right? So let's push trace. All right, right now I'm at an age of 5 and a height of 182. So I'm going to go over until I get to 200. A height of 200. Let's see. Getting close, getting close. 199, 199.56. There it is. I'd say it's that one. That one is closer than that one, correct? You see it? So at what age is this elephant when it reaches 200 centimeters? About, we're estimating. 7.9, let's say.
7.9.
Oh, just work with me.
And you're doing 7.8.
It's an 8/10 of a year through,
You
right?
just like started at one thing and just
What?
I guess it's about.
Yeah, about 7.9, almost 8.
Why did you write 7.8?
Because I just wrote a note to myself. My gosh, you guys are horrible. No, he is. 7.9 years old. How about that? Is that better?
No, you have
How about this? Almost 8, even better. How about that? Okay. So let's do this next one. We'll move on. You know you have to have story problems because they're fun. All right, graph, state the domain and range. Okay, so first let's start with a graph. This is a square root, so I'm going to start with the parent function and just sketch the parent function here. 0, 0, 1, 1, 4, 2. That's the parent function. 0, 0, 1, 1, 4, 2. Let's dissect what's happening here. What does the negative 4 do to it? Down 4. We did learn this. What does this 2 do to it? Tricky, tricky, tricky. You learned it. Left 2. Makes me happy. What does the 3 do to it? Stretch of 3. It just kind of makes it get bigger. Stretches it out a little bit. Okay. The negative 4 makes it go down 4. The plus 2 makes it go to the left 2 because the original equation is x minus h. So whatever you plug in there, right? Okay. And then the stretch. So I can just kind of work with this, or you could go to the graph and get some points. It doesn't matter to me. I'm going to go down 4, 1, 2, 3, 4, left 2, and then the stretch is kind of vague, but I'll just try it. I'll just try and draw it as a stretch. Now, my preference would be that you go to the calculator. Let's put this on the calculator. 3 times, I don't even know if you have to put the times. I just do because it's safe that way. X plus 2 minus 4. And then go to your table and get some points, some easy points off of there. Yeah, it didn't get my, there we go. Okay, so 7, 5 I see is 1. I'm going to go down a little lower. Okay, I have negative 1, 1, 2, 2. Thank you. And 7, 5. So negative 1, 1, I was pretty close there. I don't even have up to 7, so it's pretty close. Graph, now let's talk about the domain. What could x be in this graph? Yeah, x is anything greater than or equal to negative 2. Look at the x-axis here, negative 2. So that's all x can be. What can the range be? Greater than or equal to what number? 2, 3, 4. Negative 4. Okay? You try this one on your own. See if you can do it. Again, sketch the parent function first. Oh, wait, I'll do this with you. Tell me, what does the 3 do? Up 3. What does this do? Right 2. What does the 5 halves do? Not the negative, but the 5 halves makes it do what? Stretch. It's bigger than 1. So it's a stretch. And what does the negative do? Flip it. Oh, but wait. I screwed up. What did I do? I drew the wrong parent function because it's a square root. It's a cube root. So let's just convert it to a snake, sort of. Okay? There's the parent function. Now, you have options. Throw it on the calculator, get some points. That's fine with me. Okay? But know that if you don't want it, if you want to shift it, you shift it from the center. Like up 3, right 2. You can do all that. Absolutely. Do the domain and the range.